Hello everyone. Did you know you can actually measure the speed of sound with just a wall, a stopwatch, and a loud clap? That's the beauty of the echo method. In this experiment, sound is produced at a known distance from a large reflecting surface, like a big wall. The time taken for the echo to return is measured carefully with a stopwatch. And to make things reliable, the experiment is repeated several times so that we can average out the small errors. It's simple physics in action, using echoes to catch the speed of sound. Now, let's think about the journey of the sound wave. It doesn't just go to the wall, it also comes back. So if the distance between you and the wall is d, the total distance traveled by the sound is 2 times d. The stopwatch measures the total time taken, which we call t. This is very important. Never forget that the sound covers a round trip, not just one way. It's like going to the school canteen and back to the classroom. You can't count just one way if you want the full trip. Here comes the golden relation. Speed equals total distance traveled divided by time taken. Since the total distance is 2d, the formula becomes v equals to d divided by t. Here, v is the velocity of sound in meters per second, d is the distance from the wall in meters, and t is the echo time interval in seconds. This relation shows exactly how distance and time combine to give us the speed of sound. All we need are accurate measurements, and the physics does the rest. So, how do we set this up in practice? First, choose a large wall at least 50 meters away. Then produce a sharp sound, like a clap, a firecracker, or even a small pistol shot. Next, use a stopwatch with a least count of 1/100th of a second to record the time between the original sound and the echo. Repeat this several times and take the average to reduce random errors. As you can see in the diagram, the whole setup is quite simple, yet it gives a very accurate result. Let's run through a quick example. Suppose the wall is 50 meters away and the measured time interval is 0.29 seconds. Using our formula, v equals to d divided by t, we substitute the values to times 50 divided by 0.29. That comes out to approximately 345 meters per second. This matches closely with the accepted speed of sound in air. Not bad, right? Just a clap and a stopwatch, and you've nailed the physics of sound velocity. To wrap up, the echo method is a clever way to determine the speed of sound using simple tools. The sound travels a total distance of 2d in a time interval t, giving us the formula v equals to d divided by t. A large reflecting wall and a precise stopwatch are essential, and repeating the experiment improves accuracy. When done properly, the value obtained is very close to the accepted speed of sound in air, around 340 meters per second. And that's how physics turns an ordinary echo into a measuring tool.